Welcome to our discussion of Lesson 8.3. I hope your day is going well as you sit down to study with me Systems of Inequalities. Now, the last two lessons we've studied systems of equations, and I hope that you'll find that systems of inequalities aren't a lot different than working systems of equations. A solution of an inequality in xy is an ordered pair that yields a true statement if we substitute A and B into X and Y respectively. And so we have to find all solutions. Now what you're going to find as we look for these solutions, it's not just going to be a point or even a set of points here. It's going to be an entire region. And so we're going to take a look at that here as I adjust my pen. Apologize for not having that done. Some guidelines here. We need to replace the inequality symbol with the equal sign and graph the resulting equation. We use dashes if the inequality symbol is a less than or a greater than to indicate that no point on the graph yields a solution. And we use a solid line or curve if we have a less than or equal to or a greater than or equal to. If R is a region of the XY plane determined by the graph in the guideline above, and if a test point PQ in this region yields a solution of the inequality, then every point in that region is going to be a solution. And we'll see what we mean by that as we go here. So let's take a look at this first example here. And 2x plus 2y is greater than 3y plus 3. Now, if we subtract 3y from both sides, alright, subtract 3y here, 2x minus y is greater than 3. And then I'm going to subtract 2x from both sides. So what we get is negative y is greater than negative 2x plus 3. Now what you might remember is that if we have to multiply or divide an inequality by a negative number, we must flip the inequality. So y is less than 2x minus 3. And now they talk about how to graph this just for a minute. Little thinking bubble here. And I'll probably only do this once just for a minute. Think about graphing y equal 2x minus 3. Now we draw our grid. We plot our y-intercept. And our slope here is 2. And so we go up 2 and over 1. Now guys, we can go once again up 2 and over 1 more again. What you'll notice is this is a less than. With less than, if you'll remember, when we graph a less than or a greater than, we need a dashed line. And if it's less than, we're going to shade below the line. Now what I'm going to do here, I'm going to remind us that anything in this region we believe is a solution to the inequality. Anything in this region up here is not a solution to the inequality. Now, our guidelines up here tell us to pick a point in the region and see if it satisfies the inequality. What I'm going to do is I'm going to pick the ordered pair 0, 0. Now 0, 0 of course is right here. And it is not in the region we shaded, therefore it should not satisfy the inequality. Let's check this out. 2 times 0 plus 2 times 0. Is this greater than 3 times 0 plus 3? Well, let's see. 0 plus 0 is 0. Is this greater than 0 plus 3? No, it's not. We didn't think it would be. And so our solution to the inequality here is, in fact, the region that we shaded in a minute ago. Now we don't include the dashed line, and I kind of messed up there and got a little bit on the dashed line. The dashed line, because it is what we call a strict inequality, because it is strictly greater than, nothing on that dashed line is a part of the solution. However, everything below that dashed line is part of our solution. Certainly, if you have questions, bring those with you to class. Let's take a look at our next example here. Graph x squared plus 4 greater than or equal to y. This is our friend the parabola that's been shifted up 4 units. And it's a greater than or equal to, and because it's a greater than or equal to, we're going to use the solid line there to to indicate what's going on. Now, we need to be careful. We need to be careful how we read this. This says x squared plus 4 is greater than or equal to y. What this means is y is less than or equal to x squared plus 4. And so all of our y points have to be less than or equal to the y points along this graph, which means that we are going to be shading in this region everything that falls below the parabola. Again, we'll pick our test point, and again, I'm going to use 0, 0. It is in the region this time that we've shaded. Let's check this out. Is 0 less than 0 squared plus 4? Well, is 0 less than 4? Yes, indeed it is. And so we know that my solution set is the interval down here that we're shading in the yellow highlighter. Well, we've looked at graphing single inequalities. Now let's look at a system of them. And we've got a little work to do here, not a lot, but a little bit. We've got 3 inequalities, and I'm going to graph them in different colors here so that when you're watching the video, hopefully it'll be a little easier to see. 2x plus 3y is greater than or equal to 6. 3y is greater than or equal to negative 2x plus 6. And y is greater than or equal to negative 2/3 x plus 2. So I'm going to graph that in black, and let me change colors here. I'll draw my grid in green so that we don't get confused. We'll go to black here. I need to go up 2 units. And then from there I need to drop down 2 units and go to the right 3 units. So y is greater than or equal to negative 2/3 x plus 2. And since this is a greater than or equal to, this is going to be a solid line. Now the solution to this particular inequality I'm shading in black. Let's get the next compound inequality that we have here. 0 less than or equal to x less than or equal to 5. And so 3, 4, and 5, everything between x equals 0, remember these are vertical lines now, and x equal 5, everything in the red is a solution to this middle inequality. And then let's go get blue. 0 less than or equal to y less than or equal to 4. And so we know these are horizontal equations, and it is less than or equal to, so we can go with solid lines. Alright, and so anything between the blue lines is a solution to that third compound inequality. My goodness, what a mess, huh? Well, what we need for our solution here, we need everything that's black and red and blue, and we get to include all of the lines here because they're all greater than or equal to. And you guys will learn, I was never very good at coloring in kindergarten, never got high marks for shading between the lines. Let's see maybe if I can take just a second and do a slightly better job with this here. You guys are going to learn, some of you that study linear algebra more carefully, that this region that we're coloring in has many applications that are very, very useful. We'll talk, well, we won't in this class, but those of you going to study linear algebra and matrices in more detail in later classes like a linear algebra class or finite will learn that this is what we call the feasible region, and it has many great applications. So if you would, take a look at the class discussion exercises along with the homework, and we will we'll see what we can do there. Finally, one last example here, fairly short section. An auditorium contains 600 seats for an upcoming event. Tickets will be priced at $8 for some seats, $5 for others. At least 225 tickets are to be priced at $5, and a total sales of at least $3,000 are desired. Find and graph a system of inequalities that describes all possibilities for pricing the 2 types of tickets. Alright, so We are going to go back here and get my black ink. It says we have 600 seats. Let's call these the expensive seats. Let E represent number of expensive seats. Let's C represent the number of cheap seats. Okay, and we know that the number of expensive seats plus the number of cheap seats equals 600. We also know that at least 225 tickets are to be priced at $5, so those would be the cheap tickets. So the number of cheap seats has to be greater than or equal to 225. And a total sales of $3,000 are desired, so of at least $3,000. So what we know is that the expensive tickets cost $8 a piece, plus $5 a piece for the cheap seats. This is the total sales, and this total sales has to be greater than or equal to $3,000. Okay? And so now you can see that we have three equations here. And let me go ahead. Here's our grid. Let me change up ink color here. Let's start out with red. So I don't know that it really matters. Here's our expensive seats. Here's our cheap seats. If we take this equation, E equals 600 minus C. So when C equals 600, when C is 600, E is 0. And when E is 600, C is 0. And so we know we contain 600 seats. Now guys, this is just an equation here. It contains 600. That's an equal to. We're not shading above or below there, but that is going to be one of our constraints, one of our restrictions, if you will. And you'll talk more, some of you heading to finite and linear will talk much more about these constraints and so forth as you go. Now, we know that at least 225 tickets are supposed to be priced at $5. We said those are the cheap seats. Let me grab another color of ink for us here. Let's go with green. So 225, that's just barely above 200. Alright, and so greater than or equal to this, we're shading above the green. And now a little bit of work to do here. Let's get a different color, maybe blue. Sounds good to me. Alright, so if 8E is greater than or equal to, actually let's go for C here. That seems to be our, that's on our y-axis. So let's get this guy out of the way. And once again, 5C is greater than or equal to negative 8E plus 3,000. So C is greater than or equal to negative 8/5 E plus 3,000 divided by 5 is 600. Well, isn't this convenient? When E is 0, C is 600. Okay, so that point happens to be on both lines. And then let's see where it's going to cross the E-axis here, if you will. When C is 0, let's just solve this equation real quickly. I'm going to change this to an equal for the purposes of solving the equation. So negative 600 equals negative 8/5 E Negative 3,000 equals 8e. Divide by 8. And e is equal to 375. So let's see, 375 is going to be right about here. And notice that this is also a greater than or equal to. So we have to be shading above the blue line. Okay, and so where is our solution set? Well, our solution set here, and let me make my highlighter much smaller as I try to do a good job here. I don't know that it's going to let me make my highlighter smaller. Well, two ways to go about this. Let me do the following. Let me grab a pen here, and we're going to change this to the yellow. Get the yellow highlighter color without the thickness of the highlighter. Always a nice thing. And so there we go. There we go. There's our feasible region and our solution. And guys, that brings section 8.3 to an end. So certainly if you have questions, let me know. Bring your homework in and we'll take a look at the class discussion. Thanks for watching.